Alright guys, welcome back to another asynchronous video. We'll have a bunch of stuff for you today. So this first theorem here is we've done this theorem but for e, right? So e to the x, right? The Euler's number, e to the x. This one forever is for any value a, right? So this could be 2 to the x, 7 to the x, 14 to the x. Doesn't really matter. What is its integral? And there's a couple ways to see what it is. One way is from the derivative, and one way is doing kind of a creative u substitution. Excuse me, yeah, I guess a creative u substitution. But I think the easier way to see it is from the derivative. So if you remember, the derivative of a to the x is ln of a times a to the x. All right, that's the rule from last time. I guess last year. Now, if I integrate both sides, if I have two things that are equal, then their integrals will be equal. The left-hand side, right, the integral and the derivative cancel, and the left-hand side is just a to the x. Now, the right-hand side, ln a, right, so this is an integral with respect to x. So ln a, that's just a constant. I can pull that out. Ln a, integral of a to the x dx. And we notice that this is the thing I want to know about, right? That's the thing I want to know about. So I can just solve for it, dividing that ln a over to give us our final answer, the integral of a to the x dx is equal to a to the x over the natural logarithm of a. All right, so there's another integration rule to add to your tool belt. We have the mean value theorem for integrals, and it's just it's kind of a weird aspect of calculus, these mean value theorems. All it says is we can find C so that this equality is true. And how do we do that? I guess first off, let's get some physical intuition, right? So this is from A to B. This is some function. Here's some function. And there's going to be, if we look at this, right, that's the area I want to know about. That's the left-hand side of my equation. There'll be some place where we can find a C. Maybe C is right here, right? So this is B minus A. That gives you the width of a rectangle. This gives you the height of the rectangle. So that if I draw this rectangle, the area of this rectangle is equal to the area under the curve. Now, I didn't draw my C in the right place for this problem to make very much sense, actually. But that's the gist of what's going on here. And of course, we can solve this in kind of an algebraic way. So I want to say, well, we're going to find C. Find this C. We'll let f of x equal, I say, x, 1 minus x. There's a good one. And we'll go from 1 to 6. Here's a good interval. All right, so I want to find C in this interval so that this statement is true. So let's see what we can do. So we have the integral from 1 to 6. f of x is x 1 minus x dx. We want this to be equal to, well, b minus a, so that's 6 minus 1. And then f of c, remember that's just plugging in c for x, so this is going to be c 1 minus c. c1 minus c. So what I can do is I can simplify a little bit. This is going to be the integral for 1 to 6 of x minus x squared dx, which will be equal to, I guess, 5c minus 5c squared. 5c minus 5c squared. Okay. Now I integrate the left-hand side. So this will be x squared over 2 minus x cubed over 3 from 1 to 6. And let this be equal 5c minus 5c squared. And what happens is we plug our numbers in. So we're going to get what, I guess I need some more room here. 36 over 2 minus 6 cubed. 6 cubed is 3 times 6 is 180. 216. 216 over 3 minus 1/2 minus 1/3. Right? So I start to simplify this. And I will get 18 minus 216 over 3 is 72. 72 minus 1/2 plus 1/3 if I distribute the negatives, which is equal to 18 minus 72. That'll be well, watch me struggle. 62 minus 8 is negative 54. Negative 54. This is negative 53. Negative 53. And 4/6. So, no. This is 1/2. 3/6 is 5/6. 5/6. If I add all that up. So, which is equal to 5c minus 5c squared. Right, so this gives us the quadratic equation, 5c squared minus 5, yeah, it's fine, 5c squared minus 5c minus 53 and 5/6 is equal to 0. And I can plug this into my quadratic formula to find the c that gives me my answer, and the c has to live between 1 and 6. So I'll leave that to you guys to finish solving. All right, nextly we have the average value on an interval. The average value of a continuous function on an interval is given just by this expression. So if we want to find the average value of, I don't know, let's do 3x minus 7. F of x equals 3x minus 7. All I do is when we go from 1 to 8, all I do is compute this value. So I'm going to get 1 over 8 minus 1 equals the integral from 1 to 8, 3x minus 7. Oh, times, not equals, times, not equals. Which is 1 over 7 times 3 over 2x squared minus 7x from 1 to 8, which is equal to 1 over 7 times 3 over 2 times 64 minus, nilla, minus 56 minus 3 over 2 minus 7, And then if we calculate all of this, this is 1 over 7 times 64 over 2 is 32. 32 times 3 is 96. 96 minus 56 is 40. Minus, I guess this is all in parentheses like this. 3 over 2 minus 7, so that's 1 and 1/2 minus 7, so that's negative 5 halves. Negative 5 and 1/2, which is negative 11 over 2. All right, so we got 1/7. This is 80 over 2, 11 over 2. That's what? 91 over 2. So this is 91 over 14 if you simplify it. Okay, and there's the average value on this interval. All right, so these next couple of theorems, we'll actually look at them in combination with a problem. So Theorem 4 and Theorem 5 will look in combination with some problems. Let's take a peek at problem 2 here. All right, so part A and part D, those are kind of last year problems. Those are last year problems. So let's look at B and C. These are this year problems. All right, and we're given here a function we have to deal with, right? A function that we have to deal with, and it gives us the velocity, and we want to know what the position of the particle at time 3 is, right? And now here is kind of the power of what we're doing right now is we can set this up pretty easily. We can to find the position of the particle at time t equals 3, what we do is we integrate velocity, right? And then one thing we can say we could do is we can plug t equals 3 into it. So let's do that. We integrate v of t, right? So we want to integrate 10 sine of 0.4t squared over t squared minus t plus 3. And you might be saying, first off, you might be saying, what are my bounds? That's a good question. One of the fundamental theorems of calculus tells us exactly what we have to do. One of our bounds is going to be, our topmost bound is going to be 3. And our bottommost bound is actually where we start. So it's actually at time 0, right? And that kind of makes sense. Right? We're thinking about at position 0, when time equals 0, right? My particle hasn't moved yet.